The LandXML grouper may be started by double-clicking the folder icon for the FDOT 2015 State Kit and selecting the LandXML grouper by double-clicking the LandXML grouper icon. Or if we choose to close this, we can bring up Civil 3D, go to the FDOT tab, bring up the FDOT ribbon, and selecting LandXML grouper from the icon in the FDOT State Kit. I'll go ahead and close Civil 3D down just for a second and rearrange my screen.
This application reads in a LandXML 1.2 schema format file and allows the user to create point groups and chain groups that are useful when loading that LandXML data into Civil 3D. Point groups and chain groups are organizations of data where we can select groupings based on the names of points and their zone and their feature code and their DTM attribute, and even possibly information that's contained in their descriptions. The application has some predefined groups that can get loaded up from a configuration file, which we'll talk about a little bit later. But by default, a configuration file loads up automatically that contains some of the groups that are previously defined for both chains and points. As you can see here, there's some set up for the topo RD type of data that would come from survey for design, existing drainage, existing utilities, the existing DTM, and so forth. Basically, a configuration file, which we'll look at a little bit later, has this information in it, and we can supplement and add to that configuration file. We can remove these out of that configuration file or create any combination of configurations that we want on our own. The first step is to go ahead and load up the LandXML file, and that's done by File, Open, and we're allowed to navigate and go pick an XML file, and I'm going to pick a particularly large one. We'll use this 2204991 and go ahead and open that up. And what has happened is in that LandXML file, there is a default point and a default chain group already in the LandXML, because the LandXML contains a section in the data called CG points, and you'll see that that is listed here, and it contains a section in the data that contains the plan features or the chains. We're going to take just a moment and take a look at that LandXML to see where this data came from. And this data is set up automatically when data either comes over from the converter that groups data or straight out of EFB. Here I've opened the LandXML file inside of an editor that can show us the LandXML file and a little bit about its contents. As we see right here, the LandXML file has a section called CG points, and this is the overall master point list for the LandXML. You see that the name was 2204991-points, and that is why in the grouping application we saw a group already containing that name. Likewise, for the plan features or the chains, we see a section called 2204991-chains, and this is the way the data came out of the EFB program when we exported the EFB dataset into a LandXML format file. So we get a CG points section. I'll expand that, and that contains all the CG points by name, by zone number, by role, by feature code, by description that we're going to use later on in the grouping application to create groupings of data that will create point groups and figure groups in Civil 3D when we import the data. Likewise, we have the chain plan features. So we see the plan features section, and then we have each individual chain. Here's the chain CS1. It's called a plan feature, and it actually has 3 sections, and each of these chain sections that we see here refer to the listing of points that the line work is going to pass through. Because this chain contained gaps in EFB, we see 3 chain sections. So there was a gap after the first section of the chain, and then the second section of the chain began after the first gap, and then the second gap would have been here, and then the third section of the chain. But since the LandXML 1.2 schema does not support a gap delimiter in the point list, the chains have to be broken up this way. So we have an EFB chain called CS1, and then it contains sections for each section of the point list between the gaps. As we see down here, chains obviously can have a name. They can have a DTM attribute. Here the DTM attribute's feature. They can have a zone. They would have a feature code. And in some cases, as we see down here, change can have a description. So we can use these fields in the grouping application to create point and figure groups for Civil 3D, but really what they are is we're going to be using these attributes of the data to decide what groups we want to create, because it's very convenient to do that in the data. And what happens when Civil 3D reads the data, it's going to automatically create like groups in the Civil 3 data when that data is imported. I'm back now in the Grouper application. Remember, we just took a look at where this section of the data comes from. This is the master point group list, the master chain group list, and using these, we're going to create subgroups based on the type of data that we want to see. As we now see, since the LandXML has been read in, when it does come in, we have these two master groups that we see here. This view in the application is a results window that shows us the results when we create a group. From the master data, there's a whole series of point names. Those aren't shown immediately because this section of the application is basically used to create essentially a filter that is named and appears over here in this list. So these group names are really a collection of filters. And overall from the data that came in, we saw that the data contained 4 zone designations, and zones are integers in the EFB data. They're also integers in the LandXML data, and LandXML says a zone can be an integer value between 1 and 99. So we see that that data only had 4 zones defined. The data that came in had lots of feature codes inside of it, so we see that there's a bunch of listing of the feature codes, and this filter is trying to establish itself, and you see that it's checked all these particular feature codes. There was also 2 DTM attributes. There was the feature attribute, which represents objects that are not on a surface, and then there's the ground attribute that represents things on the surface. And we've already seen in the data that contain descriptions. So let's take a look first of all at these predefined groups or filters that have already been defined. So as we click around in these different filters, we can see the properties changing here that shows us what the filter actually selects. So here in the case of the topo, we see that different feature codes are selected from the data set, but we also can choose different things as well as we create additional data. The first thing I'm going to do is just go ahead and use the filter as it's set up by default, and I'm going to right click in the area here, and by right clicking I can add additional filters or additional groups. I can rename a group, I can clear a group out, I can remove a group, or create a group. When I create the group, it's going to apply the filter to the data and load the data into the results window. So what has happened just now is the filter that was created for this topo RD chains data used the information in the window here, interrogated the open LandXML file, and put the results that matched these filter settings into the results window. And we see that group data appearing down here as we applied this filter to the data. So what we can see for these chains, it's type chain, so there's the chain name, the zone, the code, the attribute, and because these are and conditions, it's this condition and that condition and that condition and that condition. You see that we have all chain names that essentially matched these selected features. Had I limited the data, let's say to zone 2 and applied the filter, we notice now that only zone 2 that matches all the conditions are shown. I could also create additional filters over here by using expressions. So let's say, for example, I wanted to have all the chains that began with the letter B, like we see here in these 2 bridge chains, appear in the list. So I could create some additional filters in the data. And this filter list allows us to use the conventional EFB selection, like using point name ranges. I could say like bridge 1, bridge 2, or I could do something like with a regular expression. So to use a regular expression, so if I wanted to use a regular expression to say anything that began with the letter B, I would use the caret character and then the letter B, and that regular expression says any point name that begins with the letter B is going to end up in my list. So what I need to do is I need to add that filter to my filter list, and then if I reapply the filter, so since that filter now belongs to this one that I have highlighted, and I create an additional group, notice now this group only contains the bridge 1 and 2 chains that match the other criteria. So you see that in doing the query selection, the filters work as an AND operation. It's this condition, and that condition, and that condition, and that condition, as we move across the filter list. If we have multiple criteria for any one of the conditions, like names, zones, or codes, it is an OR operation. So if I said begins with the letter B, and maybe let's say begins with the letter C, I don't know if I had any, and let me uncheck that and add that. And let's go ahead and create that particular group. So now, as you can see, I don't care what zone the data is in, but I want any name that begins with the letter B or begins with the letter C, and all zones and all attributes. So as you can see, these filters have OR conditions as we move down the filter list, and conditions as we move across the filter list. So we can be very, very discrete about the types of data for which we want to create a group, because we have a very powerful query with a very simple interface. If you need help on regular expressions, of course, you can go look up on the internet and look up what the different things are for regular expressions. But the most common ones we thought would probably be used for either selecting names or selecting feature codes. And of course, you can see you can check and uncheck and select, or selecting descriptions. We put in a little small help file. If you basically in the regular expressions, if you leave it blank, that's kind of like a wild card. That matches everything. Of course, you can put any character in there or no character, and that's kind of like a wild card. It'll match anything matching what's in the list. So matching blank is a wild card, or matching a particular character or series of questions. As you see here, UM would match all names containing those two specific characters. So that'd be like a UM asterisk or a wild card. You see the caret character is used to match that begins with. So like the character with the caret RD would match all names, for example, that began with the letter RD, or like you saw in this case, we did it with the $B. If you want to match something that ends with particular characters, you can use the $ character. So you can create very, very powerful filters that also use regular expressions to contain the filters. Now that we have used this particular built-in group and altered its filter properties, we can come down here in the groups that we've created, and we can rename those groups anything we want. So I could call this just as easily Fun Chains, and rename these to more Fun Chains, and so forth. So you get the picture that once we've created these groupings of data down here in our output, we can name these things anything we want. You see here also that I can remove the grouping. If I created a grouping by accident, I can take it away. Once I have a grouping created, and this is again before I do my output, I can right-click on it, and I can go and further refine and edit what is in the results window. So if I hit the Edit Chains, I'm going to get a dialog pops up that I can actually remove even more from the list, or further refine by specifying name ranges, regular expressions, and things like this. So you see we have essentially results within results, and we can do even more powerful things like increase or modify a filter, essentially just like we saw here, even though we had applied an original filter. Let's go ahead and remove these chains. And we'll go ahead and start doing some of the things that we would normally do in the operation of getting data ready for Civil 3D. Here we've seen that we have some of these predefined ones for our topography, for the points and chains that belong with that, our existing drainage, our existing utilities, our existing ground DTM, and some of the right-of-way groups that are contained. If we look at these filters essentially automatically imported. And these were some of the imports that come from a file. And what we're going to see see is the name of the file is called FDOT Group Filters.xml. So this is the default file that loads up when the application starts. And I want to open this up just a second to show you how those settings are saved in there. So if I open up that XML file, what we're going to see, and we collapse down the data, is we're going to see filters that were predefined in that list. They're not really groups yet till we actually do the data. So I've got quite a few of them in here already. But we see this various filters created for chains, these various filters pre-created for points. And you can add to this default list or modify this default list. Of course, we could do that with a text editor like I have here, but the topo RD points is simply nothing but a group of features that we see here that are the filter list for the names of the points. And there's other criteria for the filters. So you get an idea that the data really isn't that hard-coded. I'm going to close this down, and if we were to open that set of filters, it would load that set of filters into the application here. Of course, we can create our own sets of filter files or modify the defaults. If we happen to screw up the defaults so badly and we wanted to recover from that, in the filter list under import, we can recover hard-coded filters back into the filter list that are hard-coded into the application executable itself. But typically, if the file is present, FDOT Group Filters.xml, it's going to read that file first, or if we happen to go filters import file and have any other filter list file that we've created on our own, we can select that filter file and import it. So we've already got that particular filter file imported, and we can already see how we can go and modify the default filters by changing any one of the filter parameters that we see here. So for example, if I wanted to change what the existing drainage chains were or the existing drainage points were, I could make a change to that filter just by modifying the criteria, and that filter with that change would be applied when we create the group, which is going to appear down here. So you can see I can obviously rename filters, I can clear filters, remove filters, create the group based on that filter, or add filters of my own. If I have filters that I've added on my own, I can export those filters, and basically the filter is going to be exported to the file that I select to export it to. I can create any file that I want. So I can save it to the default. If I've created additional filters, I can create a filter called Bruce's Filters, if that file name is legal, and create my own set of filter lists that now contains these properties, or contains this set of filters. So as you can see, you can save and import filters that you set up, make modifications to the default filters. You can recover in case you screwed up the default filters by reloading the presets, and you can add filters, rename filters, clear filters, remove filters, or create groups from those filters. And we've already seen that if we create groups from a set of filters, we can rename the groups and things like that. So let's go ahead and try to create our own filter. So what I'm going to do is I'm going to go ahead and add a filter. So now by default it comes up and it's the 13th filter in this list, and because I had this set to chains, it's going to create a chain-based filter, and I basically have it here, and what I can do is I can go ahead and rename this to something that makes more sense. So let's say I wanted to create a filter for all trees. So there's the name of the filter. Well, chains really doesn't make sense for trees because trees are typically points. So let's remove this one and try it one more time and create a points filter that were trees. So we'll go ahead and either right click in the area or I'll add one here. Either one will work. So if we add down here, I now have a points filter, and let's make this one our trees filter that we're going to create. We happen to know that trees have a feature code that begins with something like TREE. In fact, if we go down here in the list, because of the data we imported, we should probably see something like a tree, and we could just create the filter by clicking TREE, TREEC, TREECI, and so forth. But there may be quite a few of these that we would have to pick, and it might be tedious to create that filter. But if I happen to know that every tree is going to start with tree, I could apply a regular expression that would select those. And by applying that regular expression, it went ahead and automatically selected all the trees for me that began with TREE. So now I have a filter criteria for trees set up that's going to be all points, because no additional filters applied, all zones, just the trees. I don't care whether they're ground or feature, and I don't care what their description are. So if I go down and create a group, I now have a group with all the trees in my data set. Now that you've seen how to use pre-existing filters, delete pre-existing filters, modify existing filters, create your own filters, and then once you have the filters defined, create a group, and then within the group, rename the group, remove the group, do edits on information in the group. You can lock the group down like we've seen here on the defaults. Notice these are locked. We can unlock these and then make edits to those things in the group. I'll lock it back down because I probably don't want to mess with that. But if I create a group that's locked, I can't go do the little refinement like editing the data that we saw here. So I'll unlock that so I can make refinements if I so choose. And if we unlock it, we can do these edit functions that we saw and change even further what is in the group. So it's kind of like a selection on the results of a previous selection as we saw previously. So we can make refinements to the group. We can also display data. So if we have a group that we're ready to create our output on, we can go under our file and our save as and create an XML file that contains the group. So if I wish to create a group that just contained my original master list of points, my original master list of chains, and one additional point group called trees, if I do save as, I could create a group, and what I'll do is I'll create one called grouped, and maybe take grouped out and say trees, and save that file. Now I've created a LandXML file that has the grouping for trees embedded in the LandXML. Let's take a look at what that looks like. So I'm going to open that grouped LandXML file in an editor, and I'm doing it on another screen. And now we see the LandXML file that we've created that contains our trees. We see it here. Let me close down some of this. So we have just the LandXML file that we just got through created, and let me collapse up some of the data so it shows up a little better. So in our data, our original data, we had the master point list that had all the points, and then you see a little different formatting of the data that just has the point group that contains those tree filters that we just selected. Notice that in the master point data we have all of the data, including coordinates and so forth, descriptions, geometries, and everything. We see descriptions found here, but when we created the group, the grouping is just the point names, and this is a property of LandXML that when you have groupings of data, you refer to the previous data by name. So whenever we create a point grouping, we're going to see the grouping refer to the previous data that we find up in here. So right here there is a point in this master group list called tree 5, and we have just a grouping called trees that contains these points, but it refers to the data by name. And that's why we have a PNT reference enumeration that talks about which points belong to these groups. I'm going to go back to the application and let's create another grouping so we can see how the plan features or the chains work. I'm back over at the application, so I'll go ahead and add a filter. We'll rename the filter, and that is for chains. And let's try selecting the feature code for asphalt pavement. So make sure my filter is selected, and let's try for asphalt pavement and see if we have a little better luck. So we're going to try for feature code AP, and we're going to go ahead and create our group, see what we get. So we have our group now created for asphalt pavement, and in this case it did contain some chains with asphalt pavement in it. So we can see here's the names of those chains, what zone they were on. Of course we did our filter by feature code, what attribute they happen to be, and then their chain list is shown to us right here, and also their description in case we need to do any more refining of what contains in the group. So what I'm going to do is I'm going to go ahead and output the LandXML file again containing our master list plus our two new groups that we just created, and let's take a look at the plan features in the LandXML for these two groups. So I'm going to go File, Save As, and let's create another LandXML, and let's say trees and pavement. something like that. And then we'll go ahead and open up that LandXML and see what we've got. So I've opened the LandXML. We've already seen we have the master list of points. We have the group for the trees that we saw in our grouping list. We have the master list for all the EFB survey chains that's going in. And let me collapse this up now. And now we see we have our group list for our asphalt pavement. And notice again, just like we saw with the plan features for the tree groupings, we have a plan feature grouping or a figure group in Civil 3D parlance for the asphalt pavement chains that we're going to create the group by. Again, these reference the master list by name. So now that we have these groupings, the next step is, if we've got all the groupings that we want to create, is to go ahead and load the data into Civil 3D, which will automatically create these groupings for us because they exist in the LandXML data when they come in.
A special case of using LandXML Grouper is when we need to create pipe networks from the survey. If we open up a file and we wish to create pipe networks, two special groups are shown down in the very bottom. One is to create the existing drainage pipes, and the other is to create the utilities pipe network. Here we have all the drainage features set up, and if we create that group, the data is interrogated, and all the feature codes matching drainage items are loaded into the database, and all the drainage features are loaded up. We can then save those. Then we'll do the same for the utilities. Let's first remove this one. And now we'll go ahead and save it for the utilities. And now we have two grouped XML files that contain the pipe network layouts. When we import that into Civil 3D, we'll actually get pipe networks for our existing drainage, and we'll also get pipe networks for our existing utilities.